Alright, welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. We are still developing unassemblize tool building the GUI. Since a couple of videos already, and what do we got? We got this. I think we wanted to hook up the buttons here. Maybe, I wonder if we should maybe move these buttons to the bottom. Because it doesn't make sense that someone... Let me think. Does it make sense here? Because usually you start like filling out the top and then you click load, save config, right? Yeah, maybe we should move it to the bottom. Why do we have so much scope here? What is that? Let's take that and move it here. Let's call this buttons. And we can remove this. Let's call this action buttons. Yeah. I think this is too tight packed together here. That's not good. I wonder if there should be maybe a separator. By the way, why do we have a scope here? What is that? Why do we have so many scopes? Okay. How about we put empty separator text here? Let's see how that looks. Oh, I think there's also something called spacing, no? Spacing. What does that do? Vertical spacing. Okay. Maybe we should do that. Spacing. Let's see. Yeah, now it has a bit of spacing here. Yeah. Okay, how about we go to ASM, no, options, none. How is this used? Okay. Okay. So let's get back to ImGUI app. So the disabled button loads. Loads. Okay. Input files. Let's rename this to program files. Program files. We call this program file descriptor. Okay, so I think we can activate this descriptor dot input type disabled if this equals none, right? Then it should be disabled. Let's see. Okay, so this is now grayed out. So if we now add some here, okay. So we need to type something at least so that this evaluates to executable. Yeah. I mean, it could still fail to load, but at least like you need to type something. Otherwise it's disabled. Yeah. Okay, I think that is fair. Okay. And save config should only become active if we actually load it. Yeah. Okay, so I think in our program file descriptor, we need to put executable. std unique pointer executable. Executable. And also std unique pointer pdb reader. pdb reader. How about we rename this Control Shift Alt R. Input file. I can't remember what naming convention we use. It's all over the place. Naming conventions is horrible, I have to say. Like sometimes we write it like this, camel case, and then other times it's the underscore. The Thyme naming convention is utter garbage. It is garbage. I don't know why it's picked like this, but it's absolute trash. It's trash. Because it's just inconsistent. I never know how to write things because it's just mismatching with all sane conventions. Yeah. Okay, let's rename this to something a little bit more sane. Well, that is not so sane. Okay, so we have a bunch of things. Okay. Good. Okay, then let's look in our work queue. So we have process exe. But process exe is not really what we want to do. Let me see. Process PDB. Let's rename this here as well. PDB reader. Okay, I think we need to so process PDB. Okay, I realize that we also need a command sub queue where we can, or a bundle where we can chain certain commands that belong together. So for example, if we want to load a PDB, yeah, but with the PDB, we also together want to load the executable. But the problem is that for the executable, we also want to pass then the PDB reader results here. How do we do that? Huh. I think we shouldn't do any renaming yet here. This should be a separate path, I think. Let's revert this stuff. Okay. Shit. So the thing is, we would like to have singular commands to do one thing. But one thing may depend on another. So for example, loading the executable. We want to do this. But we can't. We would have to. How about? How about we just provide a callback? So when something is done, it calls a callback, which allows us to put a lambda and say, hey, please do this. And if this is done, then do that. Right? And then we can use the result actually to form the new thing. Yeah. We could do that, yeah. Maybe. Let's see. So work Q command. Okay, so I think here we need to have like a std function call, let's say, a complete callback. Std function. Include function. Function C++ std function. Functional. So, sorry. std function overhead. Yeah. I rarely use std function. Typically, we just put a function pointer. Um, But let's wait. Callback. City function versus function pointer. Not being able to capture some context. Pass a lambda. Store a function. Yeah, I don't think that the callback is really performance critical, so it's nothing we need to worry about. Okay, so how do we say function? What do we pass? Voids. Functional. Void. I don't know. We pass. I think we pass this, no? No. We pass it a work result. Work results. So we forward declare work results. And then we give it this. Can we actually put names here? No. Oh, we can. Oh, that's wild. Results. Let's actually make it a reference. How about we put here bool consumed. Consume. So that we can consume the result in the callback already. Right? So it doesn't even go into the queue, into the result queue. So you don't even need to try dequeue it here. By the way, I think we should rename this to enqueue command. I don't think so. Bool consume. Or we just make it return a bool. Bool. But then we need a comment. When consumed is set true, then then the result is not added to the queue. Consumed is set true, then the result is not added to the queue. Optional call back to when optional callback optional function callback when the command has been completed. Optional function callback when the command. Optional function callback when the issued command has been completed. Yeah, okay. But the problem is, hold on. No, we can move from this, right? Work queue results. So try DQ. Yeah, we can move to our result. So we should be able to take it with std move, I think. We'll see. Okay, so we have this callback here. Good. Then when consumed is set true, then the result is not added to the queue. This can be used to chain commands. Chain commands with lambda functions. This can be used to chain commands with lambda functions. Okay. So okay, so here we move the command on there. Okay, so the result here is ready. So if result command dot callback what? Oh, it's a pointer. Callback. How do we know it's set? Bool. Ah, okay. So if callback, then callback, and then we need to pass the results and bool consumed false. So here we pass consumed, and there is a problem. Right, we pass it like this. The question is, should we pass it a result pointer though? If consumed, if not consumed, then we enqueue. Otherwise it will be just deleted here. Work queue command pointer. So the question is, should we give it a pointer instead? Because on here we also consume with a pointer, so we should probably give it pointer. Yeah. Can we move this here? Maybe. So give it the pointer. I just hope. I wonder what happens if we would release this guy in the callback. Like we take the pointer, we move it, and then the scope ends, the callback ends. Then what happens? um, I'm not sure. Maybe. Oof. Auto callback equals std move callback. Maybe we should do it like this. I don't know if it's necessary. Like let's ask our friend ChatGPT. If we have, I think we need to open it. So let's say we have structs as std function void func and void function let's say std unique pointer as std unique pointer s dot reset new s Let's actually write this in here so we get compile error. So let's say we have the struct void run as reset new s, and then we have another function. No, we just use lambda. Void no s dot func equals lambda this s, and we do s dot reset return no how do we assign this? S func function std bind no, we just assign a lambda here. Okay, this should work. Why is this not working? Unique pointer has no member func. Oh. Right. There we go. Okay, so this would be the pitch. Is the following code legal? Can we modify or can we delete? Can we delete struct s when inside? Can we delete struct s inside the function callback? Inside the function, inside the function lambda function. Yes, it's legal. Captures a reference and resets it, effectively deleting the s instance it points to. When s-func s is invoked, the lambda will delete the s instance by resetting the unique pointer. Since s is a unique pointer, once it's reset, the memory owned by s is released. S will no longer hold an s object. Okay, so according to this, it's legal. Hold on, I think I forgot something. We didn't call it yet. Here. Here, S. Let's ask again. I forgot the last line. I forgot to add one line of code at the end. Can you check again? Let's see. Aha, no, what? This updated code invoking as func as will indeed cause a problem. Is set to a lambda. It takes and calls as reset on it. Okay, but that's not. That's actually wrong. What it says here. But this is wrong. ChatGPT got this wrong. This one is not invoking yet. Only this one is invoking the first time. Does not. Okay, ChatGPT is confused. Well, it's okay. Yeah. So to me, it looks suspicious because I mean this is fine. Here we just assign the lambda. Good. So it just has the function address saved there. Here we are invoking. Basically, we are invoking the function callback on S. So what I wonder is, like, can this properly return without error when S is deleted inside the callback that it's actually calling here right now and has not returned from yet? So that's a suspicion. Okay, let's keep that in mind. I would like. It's actually a really curious case. Yeah. So this could be the workaround. So let's put this here. Let's put this here. Yeah, let's put this here. So it's callback results. Good. And then we comment out this guy. Let's see. What's the problem? I don't know what the problem is. Oh, right. We need to pass two things. Consumed, right. Okay. Okay, so let's use this. ImGUI app. Good. So loads. We need some other stuff first. To do is this safe? Okay, so let's go. Jesus. Let's go to execute. No. What am I doing? I'm losing my mind. Okay, work queue. Right, we need to add a new command here. Load exe and load pdb. Yeah. Just that, just loading, nothing else. Okay, so then we do a struct. Yeah, let's call it exe load options. And there we put these guys and this. And verbose, yeah, why not? Okay. And then we create a, yeah, that's good enough for now. Okay, load options. And then we need here PDB load options. And there we put just this. And then we also take this thing, put this here, and same here. Okay. Okay, then we go here and we add some nice static load exe, and load PDB. Exe load options. Good. How about, hold on, load options. Okay, before we continue here, how about we, boy, made already so many changes. G options. The compile. I wonder if we should already submit this change here, where we allocate the console, which is this stuff here. let's rename s auto str back to what it was, because it makes a change more complex. To input type, this is use. Yeah. Runner. Options. Okay, so maybe this is already complete. What about this here? To input type. I think we fixed that when we touched the console. Um, I think we have to take this. And this. But not this yet. Yeah. Oof. So we just take this. and this. And this. And this. Okay, so we have options that. Yeah, I think that's it. Okay, remove default console on Windows. Spawn or allocate console when no GUI is used. Remove default console on Windows. Allocate console on Windows. Allocate console when no GUI is used. But allocate console. Okay. I hope that this is correct. Let's stash and see if it compiles. Uh-oh. Error. Oof. Options. Okay. .cstr. Okay. Then we need to merge this. By the way, let's run this to just make sure it starts. It does. Good. Okay. Then we merge this down, amend changes. Yes. Then we stash pop, and then we remove this here again, and we compile. Reloads. Yo, what's going on here? Some crazy files here. Good. Then let's go to our work queue. No, our runner. So our runner, we have now added this stuff. So exe load options. Then we add a new struct exe save config options. Okay. And then the save config options. Save config options, dump sims. What does print sex do? Print sections. Okay, exe save config options. Struct pdb save config options. So basically we just pass it pdb reader. That's it. That's it. PDB reader. Make const. Const PDB reader. PDB reader. There we go. And then here should be executable. Executable. Dot, 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 dot. Okay. And then let's see if it compiles. Oh shit. Yeah. So we have load exe and load pdb. So, and then we do load exe. Then we do static bool save exe config and save exe config as pdb config. Save config. Save config. Okay, then let's go here. All right. So basically we split up the process exe and process pdb into two each to have finer control over the action. Like loading is one action and saving the config is one action, right? I think we can also say here verbose and here save config verbose and here as well. I think we can remove null pointer from here because we will set it here. Okay, so this one, yeah, must return a value, I see. Okay, so let's see. Dump some slot config. Okay. Okay, there's some additional logic here. Okay, how about we do the PDB first? That one is easier. Let's copy it. So load PDB. PDB reader. Read, reset, return PDB. Save config. Okay, so here we simply do if, well, let's do assert o dot pdb reader It's not null pointer. And let's do if o.verbose save pdb config file how about we do a std cout save pdb config file assert o dot pdb reader pdb reader currently does not read back config. So pdb save config options config file config file config file okay. So pdb o.pdb reader save config file. Okay. std cout includes iostream. Is that iostream? Yeah, I think so. Okay, save pdb config file. Maybe we do fmt format. Save config file. %s s dot input file std end line. What's the problem here? PDB reader. Save config. Why is that not const? Oh, there's also verbose here. Look at that. Okay. Load config. Okay. So PDB save. Options. So we don't need the verbose, but we need the override sections. False. Save config options. Looks like we don't do this. We just do save config o.override sections. And PDB reader, this guy needs to be const, no? Const. 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 Yeah, looks like I just forgot it. Yeah, okay. The other functions already are const. Good. Okay, then executable runner. Good. Okay, so PDB save config should be done, and that's pretty straightforward. Yeah, and load PDB. Not PDB reader. Reads does not read back config file. Yeah, we don't need this. And we don't need this. Yeah. Okay, this should be done for PDB. Good. So we got, we need to return here. Save config, return. Okay, return this. Okay, good. Then let's go to load exe. Load exe. Okay. Okay, let's just copy this whole thing, drop it here. Okay, so print sex we don't have. Let's comment this out. To do make configurable. Okay, now the question is, yeah. Safety submits override exe. Okay, so save exe config, that should be similar to this. If O executable is not null pointer, and O executable save config dot cstr, and that's it. It's also not const. Look at that. Const. Const. What now? Oh, it doesn't return anything. Pass the config file if it already exists and update it. Oof. It's kind of weird that it does so much decisions on its own. It makes the flow. Things like this make flows more complicated, right? Like it does not just become a save config, but it becomes load config, update, save, right? So it's counterintuitive in a way. Yeah, but okay. As long as it doesn't hurt us in any way, I guess we don't care right now. But why is this? Oh, right. This one always returns true. I guess we say return fs dot good, right? Boy. Boy. What about PDB? Save config. Yeah, we can do the same here. Why did I put it in the scope? fs.good means it should have saved it without error. Let me see. Fs good. Fstream good. Returns true if none of the stream's error state flags is set. End of file reached. Good bit. No errors. My understanding of iOS good is as long as nothing errors, like no write errors or open or anything like that, then we're good. Maybe here we should say if fs dot open or is open. I don't know. Let's ask ChatGPT. Is oh. is this is the following code legal if fs failed to open? Question mark. Fail state. Following will not perform any operation on the file, but it will not cause a runtime error or throw an exception. The code will simply do nothing. Any operation to write to it will silently fail. Okay. Okay, I guess so. I didn't actually know. Okay, interesting. Okay, so you don't need this check. Okay. Okay, that's good. Let's also ask, is fstream.good good call to make to check whether function open or write out was successful? It's not the best way. Good checks for a broader state. More precise. Good might still return true after an unsuccessful attempt to open a file. Oh, okay. Fail or bad states. Use fail or bad to check. Okay, how about checking is good and is open and good to verify write success. Fs is not ideal. Well, here's why. Is open only checks if the file stream is open, not if the last write operation was successful. Good checks if the stream is completely free of errors, which can be too broad. Doesn't directly indicate whether the last write operation succeeded or failed. You want to specifically check if the write operation was successful. It's better to use fail. Use fail and bad after a write to verify the write success more accurately. Okay, let's ask. Okay, C++ fstream check if write out was successful. Do we trust ChatGPT on his assessments? So it says check fail bad. Ugh. Good. No errors. Good. EOF bit. Good returns false. Aha. Good bit. EOF. True. Okay, fail. Fail bit. Fail. Okay, so. Okay, so fail includes bad, so we can just use fail. Okay. Okay, so I think what we can do is now the question is the fail bit actually also set when the file open fails? Is the fail bit set when fstream fails to open a file? Yes. Okay. This means... Okay. Does this mean testing fs.fail is enough to verify that the file has failed to open or write out? Yes. Why didn't he tell me the first time? I had to dig now. Okay, good. Okay, so we test for not fail. Okay, there we got our answer. I never knew this. It's actually the first time. I always thought that good is enough, but it's not fail. Interesting. Do we use good anywhere else? Let's see. Good. Good. No. Yes. Here. Okay. Okay, then we should say here, if not fail. And here we say, if fail. If fail. If not fail. Okay. Okay. fs fail. Load config. How about we make this also return a boolean, bool, false, bool, return true. What about PDB reader? Load config already as a bool. Good. Okay. Then let's get back to runner. Okay, so we have this. Good. Okay. Then we just need to sort this here. Maybe we should also assert let's do assert .o config file empty, not empty. assert o dot input file not empty. Load PDB, same thing. Okay, so dump symbols, basically we just say if config file is not empty, then we load it, right? Yeah. And we don't call print 6. Okay. Okay, that looks simple enough. Okay, let's see if that compiles. Okay, it does. Okay, I think this is a good point to take a break here. So then in the next session, we will hook these new guys up here into our GUI and call them. And then we see what happens. Good. Yeah, I think we made some progress. Still a lot to do until our... I would say our first goal should be to get the file manager up and running. And then we can conclude that part, submit it, and then move to the next thing. But I think that would be already a great milestone if all the file loading stuff is there. So we can select files. They are... The PB is loaded, the executable is loaded. We can save the configs, and that's it. That's it, yeah. I think once we have this, it's a good starting point then for the rest of the GUI. Yeah. Good. I hope you enjoyed. I wish you a great day or night. Until next time. Goodbye.